Welcome students to Agrawal Structural Academy. Now here today we learn the flexibility matrix. Now this is the equation of this matrix. The dq is equal to dql plus f into the q. So dq is the initial displacement at the coordinate. Displacement means what? Initial means any sinking of support or any initial rotation of the support. Then dqn is the displacement at the coordinate due to the external load. Then F is the flexibility matrix and the Q are the unknown forces. Now some primary information we here. Now suppose here, if you consider a simply supported beam, if you apply here moment any m, so this will deflect like this. So this is your IA and this is our IB. So in this case, this IA is equal to M by L into 3EI and IB is equal to M by L upon 6EI. Now suppose instead of M, if you apply here a unit moment, so in that case this is the slope at A, slope at B. So this IA becomes, instead of M there is a 1, so it becomes L by 3EI and IB is equal to L by 6EI. And again now we require here, suppose a simply supported beam. Suppose this is the W and this is A and this is the B. So this deflect like this in this. So here is a slope IA, this is slope IB. So this IA is equal to W into B divided by 6EI into L square minus B square, and IB is equal to W into A divided by 6EIL into L square minus A square. Now suppose here the beam is subjected to a UDL W and having the span L. So this will deflect like this. So here is IA and this is the IB. So here IA is equal to IB and that is equal to WL cube upon 24 EI. So these are some information which are required to solve the problem. So now we take here the small example. This is the support A and is subjected to load W 50. This span is the 3 meter and this span is the 4 meter. Now during this flexibility matrix, the first step is to find out the degree of indeterminacy, the DI is equal to. So unknown force minus the number of available equation. Here unknown, if you neglect the horizontal force because this load is vertical, so 2 unknowns here and 1 is here, so unknowns are the 3 and the available equations are the sigma Fy and the sigma m, because we neglect the horizontal force. This is 2, so is 1. It means we have to release the 1 forces from here. Here is 1 force vertical here, RA, RB, and here the MA. Among these three forces, we have to release the one force. So here we release the MA. So now RA and this is RB. Now here our unknown is now is MA. You are release the moment, so you have to apply the unit force at here 1. If you remove the reactions, you have to apply the unit force. If you remove the RB, you have to apply the unit force at the RB. Now here we have removed this moment, so you have to apply the your unit moment. Now our formula is dq is equal to dql plus f into q. dq matrix here, this di is 1, it means we have to develop the 1 by 1 matrix. If di is 2, it means the matrix size is 2 by 2. Di is 3, it means matrix size is 3 by 3. His di is only 1, so our matrix size is the 1 by 1. So here dq is the initial displacement at the coordinate. Which coordinate? This coordinate. So there is not given any initial displacement, so this value is the 0. Now we want to find this F matrix, means flexibility matrix. Means we have to find out the rotation at this A due to slope at A due to this rotation of this unit moment at 1. So if you write here 1, so this will reflect like this. So this is our the IA. So this flexibility matrix is nothing but the this flexibility matrix. Now here is a no 1. So now here we have to develop this F matrix. So it's not I, is F. So this is the coordinate is 1. So F11 is equal to, now already with us that this is nothing but the our flexibility matrix is L upon 3EI. So here is a L upon 3EI. So that is equal to, L is how much? It's 7 divided by 3EI. So we got the value of here F matrix. We got the value of Q matrix. Now is Q. Q is the unknown forces. In this case our unknown force is MA. So this becomes the MA. So we got the value of dq, we got the value of F, we got value of Q. Now remaining is the dql. So dql is the here 1, because here only 1 is a dql is the displacement due to external force at coordinate. Means our coordinate is this 1. So displacement at 1 means slope at 1 due to this load of 50. So this dql is equal to, the formula is W into B by 6EIL into L square minus B square. So it's 50 into 4 divided by 6EI into 7 into 7 square minus again 4 square. So this becomes here the 157.14. So as per the equation, this we got all these values, so put all these value into this equation. That dq is equal to dql plus f into the q. dq is the 0 is equal to now dql. So this is the now here due to this load 50 kilonewton, this slope and this slope both are the same, that is why this value is the positive. So dql is equal to 157.14 divided by ei plus, now flexibility matrix is 7 by ei into q is the ma. Now solve this, take here this, so this ma is equal to minus 67.25 kilonewton meter. Now here this minus sign indicates what? We have applied the rotation in the clockwise direction. The answer is the negative. It means this MA direction is the anti-clockwise. If this value is positive, so apply the moment in the same direction. But here we have applied here rotation in the clockwise direction at one coordinate, and the final moments are the minus. It means here the moment is not in the same direction, in the opposite direction. So is minus, it means is the anti-clockwise. So we got the value of here MA. This is load of 50, is 3 meter and this is 4 meter. So we got this value of MA 67.25. Now then draw the BMD here. Now for this simply supported, the bend moment diagram is WAB by L. WAB by L, so that is equal to 50 into 3 into 4 divided by 7, and at here this moment creates here the hogging bend moment. So this is minus 67.25. Here bend moment is 0 because simply supported, so join this minus and this plus. So this is the final BMD by flexibility matrix method. Thank you.